Thank you everyone for giving me a chance to present my research paper. So my research paper based on the nanovesicles from red blood cells, a potential dual mode therapeutic approach. This is called like chemo photothermal and photodynamic. So here is the introduction. The miscells, polymeric nanoparticles and liposomes are the example of nanoparticle with cancer treatment approval. The main aim of this study is nanovesicles from red blood cells, a potential dual mode therapeutic approach. So for the better treatment of the therapeutic and all the things. So both the hydrophobic drug CPT and the amphiphilic photosensitizer ICG have been investigated in this our research paper. So coming to the next slide. There are some procedures like that. The first is the preparation and characterization of ICG and CPT loaded vesicles. So in that, red blood cells were extruded to create vesicles. The size and shapes of these were measured and analyzed using transparent electron microscope. And the particle had a core and a cell, making them virtually spherical. The average vehicle size was between 80 and 120 nm, which is ideal for pharmaceutical use. We found that thickness of the bilayer is around 8 nm. This formula previously reported DLS was used to access the nanoparticle suspension size as a part of analysis. So all this we have to perform to identify the cancer treatment new therapeutic approach. So here are the some figures like slide A is telling that for vesicles higher concentration ICG resulted a better loading efficiency. As we can see the in the first for a figure A, the around 80% of ICG at a concentration of 200 gram per ml was partitioned inside the nano RBC's membrane. Incubation of RBC and ICG cause the amphiphilic compound a partition rapidly inside the rapid bilayer. RBC membrane component have a high affinity for ICG, which greatly affects its stability in water. So surprisingly, loading efficiency of CPT rose with CPT concentration immediately after ICG was loaded, but afterward tended to decrease. Now next third part is the in vitro study. So we have performed in vitro studies also and as well as in vivo studies. In vitro studies, this is called cell uptake study. Uptake of ICG and VE and free ICG was measured after induction all cells for various amounts of time. Figure 2A shown that fluorescence intensity of the living cell population was much higher than that of untreated cell, as you can see in this figure. So additionally, by linking the gross absorbance of the ICG calibration curve and assuming a seeded cell density of 10 to the power 5 cells per well, and estimated of ICG concentration per cell was achieved. Contrast at each time point, absorption of free ICG was 3 to 4 times greater than the uptake of an equal concentration of ICG and VE. This was likely to case due to the fact that unbound ICG molecule may diffuse into cells far more quickly than vesicles can be taken up by endocytes. Now this is in vivo studies we have to also perform, and the purpose of this the research looked at how long ICG loaded vesicles stayed inside the subcutaneous EAC tumors. Subcutaneous injection of EAC cells was performed in the lower right leg, and then 50 51 ICG and VE was injected directly into the tumor. So animals were scanned for ICG fluorescence after being injected with the same amount of material into their leg, left lower leg, and excited at 745 nm. At each and every time point. Tumor in mice showed a strong fluorescent signal, as we can see the figure in next slide. As a result, modest fluorescence was seen at the intramuscular injection site left. Even 15 injection. When injected intramuscularly, nanovesicles are likely to spread quickly throughout the body. Unlike other injected substance, nanovesicles remain within the tumor for up to the 72 hours. This is a huge success to justified about this cancer new therapeutic approach. After this tumor for up to 72 hours after administration, because of the absence of lymph vein and the nature of the tumor blood arteries, this was probably a symptom of heightened permeability and retention effect. These results provide evidence for the safety and efficacy of intratumoral injection of ICG and VE-CPT in case with superficial or easily accessible tumors amenable to localized lesser eradication. So, uh, in this slide, we can say that we have given the ICG injection left side of the, and here you can see the result. This is without laser and with laser, and the amount graphical presentation shows the efficacy of this study. So, in conclusion, reassembly of RBC into stable nanovesicle is facilitated by the pre-nursing of the hydrophobic drug CPT and the amphiphilic photosensitizer IC into the RBC bilayer. Higher toxicity is achieved because of the system's ability to create ROS in response to infrared laser irradiation, a result of additive action of CPT and ICG. Effectiveness of the dual treatment was seen, and this may attributable to the nanovesicle prolonged retention in the mouse tumor. As a result of potential as a dual therapy tool is to be needed. Thank you. This was my presentation. If any question, welcome.
Is there any question? Then you can ask to sir. No, sir, there is no such question. Thank you, sir, for your kind presentation.
Okay.
Thank you.
Thank you. Thank you. Thank you, everyone. Thank you.